How do encryption protocols impact internet connection speed? Imagine sending a letter in a sealed envelope versus an open postcard. Encryption protocols are like that seal, keeping your data safe but adding some extra steps. When you browse the internet, your data is transformed into a secure format before it travels. This process involves encrypting data on your device and decrypting it on the server side. Because of this, your device needs to do some math to scramble and unscramble information, which takes time and uses processing power. Stronger encryption algorithms like advanced encryption, standard to 156 bits, requiring more calculations than simpler ones like advanced encryption, standard 128 bits. This extra work can cause your device's processor to work harder, which can slow down data transfer slightly. For example, encryption can increase CPU usage by about 15 to 30% and add 50 to 100 milliseconds of delay in network communication. Hardware acceleration tools like Intel's advanced encryption, standard new instructions can help speed up these tasks, reducing the impact. Encryption protocols also add extra bits to your data, called overhead, which include headers and handshake information needed to establish a secure connection. These extra bits make the data slightly larger, which means more data is sent over the network. While this increase is usually small, it can add up if you're streaming high-definition videos or downloading large files. The process of encrypting and decrypting data introduces some delay, known as latency. For most web browsing, this delay is barely noticeable, but in activities like online gaming or video calls, even a small delay can be felt. Newer protocols like Transport Layer Security 1.3 aim to reduce the time it takes to set up secure connections, helping speed things up without sacrificing security. The choice of encryption protocol and algorithm also matters. Symmetric encryption, like advanced encryption standard, is faster and used for encrypting large amounts of data. Asymmetric encryption, such as Rives-Chamir-Adelman or elliptic curve cryptography, is slower and mainly used for exchanging keys securely. Virtual private network protocols like Internet Key Exchange version 2 with Internet Protocol Security often provide quicker connection setups compared to older protocols. Network factors also influence how encryption affects speed. Using a virtual private network encrypts your traffic but routes it through an additional server, which can increase latency. However, in some cases, encryption can help bypass internet service provider throttling, which slows down certain types of traffic. Additionally, some encryption protocols work with data compression, reducing the size of data sent over the network. This can help offset the extra data overhead, but it depends on how well the data compresses. In real-world terms, even though encryption adds some extra steps and data, advances in hardware and protocol design have minimized these effects. The small slowdown is often a fair trade-off for the security and privacy encryption provides. When it comes to the infrastructure of the Internet, including content delivery networks, Internet exchange points, and data centers, encryption remains a vital layer. It helps protect data as it travels across fiber optic cables, undersea cables, and through various servers. Network providers often optimize how they handle encryption to keep your connection both secure and fast.